All right, continuing with learning new ways to solve quadratic equations. So in 9.3, we're going to be talking about the quadratic formula. So a little review here. So we're going to find the square root of each of these. So I have 36, which breaks down to just 6. And then square root of 180. This one's not a perfect square, so we're going to break it down. So I initially see 18 and 10. 18 becomes 9 and 2. 10 becomes 2 and 5. 9 becomes 3 and 3. There's my pair of 3s. There's a pair of 2s. So then that becomes 6 root 5. 3 times 2 is 6. And we have our 5 left on the inside. All right, so a little extra practice of factor and solving. So then here, what multiplies to negative 21 and adds to 4? Let's go 7 and negative 3. Do our box. And we get x squared, 7x, negative 3x, and negative 21. So then here I get a negative 3 because that is negative. I get x, and then 7. So x minus 3, x plus 7 equals 0. And then I get x minus 3 equals 0, and x plus 7 equals 0. And so here I get x equals 3 once I add that 3 over, and x equals negative 7 once I subtract 7 over. All right, number 4, still factoring solving, so we need to get it set equal to 0, so we need to add that 4 over. It does not combine like any terms, so I get 3x squared plus 8x plus 4. So then our x, 3 times 4 is 12, and 8. What multiplies to 12 and adds to 8? That is 6 and 2. Do our box. And so remember, we're just rewriting this equation there. So there's my 3x squared. My 8x is made up of those two. So I get 6x and 2x. And then 4. Now we're looking for our GCFs. That's 2. That one's 3x. This one is just x. And that one is 2. So that gives us 3x plus 2. And x plus 2 equal to 0. So then that gives me 3x plus 2 equals 0. And x plus 2 equals 0. Solve, subtract 2 here, and we get 3x equals negative 2. Subtract 2, and x equals negative 2. Divide by 3, and x equals negative 2/3. And so there's our 2 answers there. All right, so our essential question is, what is the quadratic formula and how can you use it to solve quadratic equations? All right, so derive the quadratic formula. I'm actually going to put this out there for an opportunity for some extra credit. Anyone who's willing to find the derivation for the quadratic formula and then come do it before class, I will give some significant extra credit to. Okay, so let's first jump into what is called the discriminant, which is part of the quadratic formula, and we'll get into what the full quadratic formula is shortly after that. All right, so using the discriminant to determine the number of real solutions. So the discriminant is this b squared minus 4ac, and there's 3 cases that we have. We have when it's greater than 0, when it's equal to 0, and when it's less than 0. So when we are greater than 0, the number and type of solutions is we have 2 real solutions. When our discriminant, the b squared minus 4ac, is equal to 0, we have 1 real solution. And when it is less than 0, we have 0 real solutions, which means we have 2 imaginary solutions. All right, so let's look at number 5 here. So there's our A, our B, and our C. So we want b squared, so that's negative 4 squared minus 4 times A, which is 1, times 3, which is our C. So negative 4 squared is 16. 4 times 1 is 1, times 3 is 12. 16 minus 12 is 4. Now we don't care what the actual value is. We just care, is it greater than 0, equal to 0, or less than 0? So this is greater than 0, which means we have 2 real solutions. And let's look at 6 here. So our B is negative 2. Minus 4, our A is 1, our C is 2. Negative 2 squared is 4. 4 times 1 is 4, times 2 is 8, and we have a negative. 4 minus 8 is a negative 4. Again, we don't care about the value, just with the actual greater, or essentially positive, 0, or negative. In this case, it is negative. So we have 0 real solutions, or 2 imaginary solutions. All right, so your turn to do number 7 and 8 and see what you get for the number of solutions. All right. Now the big one is solving equations by using the quadratic formula. So with that, let's actually talk about what the quadratic formula is. So it is x equals negative b plus or minus the radical of b squared minus 4ac. So there's our discriminant that we were using before, and then that is all over 2a.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, and so as you can see, there's a nice little song. There's many variations. You can look them up, but the key thing is you need to memorize that formula. So as we go to solve using the quadratic formula, we identify, just like we have before, our A, B, and C. And then we're going to substitute that all in. So we get x equals negative b, which is 3, plus or minus the square root of b squared. Let me write it with parentheses here. And then minus 4 times a, which is 2, times c, which is negative 5, all over 2a, which is 2. And then from here, we simplify. So we get x equals, that is a negative 3, plus or minus. 3 squared is 9. And then multiply. I go 4 times 2 is 8. 8 times 5 is 40. And then we have 1, 2 negative, so that is a positive. And then 2 times 2 is 4. Continue to simplify. So we get x equals negative 3 plus or minus the square root of 49 all over 4. We get negative 3 plus or minus 7. Square root of 49 is 7 over 4. Those are now like terms, so we can combine those. So negative 3 plus 7 is 4 over 4, and then negative 3 minus 7 is negative 10 over 4, and those both reduce, giving us 4 over 4 is 1, and negative 10 over 4 is going to be negative 5 over 2. Okay, so let's do that again with number 10 here. But first I have to get it set equal to 0. I'm going to subtract 2x over. It doesn't give me any like terms there. So I get 0 equals x squared minus 2x minus 4. And then from there we do our quadratic formula. So x equals negative b. So negative, our b is a negative 2 this time, plus or minus the square root of b squared, which is negative 2, minus 4, times a, which is 1, times c, which is a negative 4. And then all over 2a, which is 1. Simplified 2 negatives there, make a positive 2 up front. Negative 2 squared is 4. 4 times 1 is 1. Times 4 is 16, and then we have 2 negatives, so that is a positive 16. 2 times 1 is 2. So then we get x equals 2 plus or minus the square root of 20 all over 2. And then 20 we can break down to 4 and 5. 4 becomes 2 and 2, so there's a pair of 2's. So this becomes x equals 2 plus or minus the square root of 2 root 5 all over 2. Now, we can reduce here. So what we need to check is all 3 terms here, do they have something common? In this case, I'll have a 2. So I can factor a 2 out of there, which gives me 1. Factor 2 out of there, which gives me a 1. Factor 2 out of there, which gives me a 1. So that gives me x equals 1 plus or minus 1 root 5 all over 1, which we don't really write over 1, and we don't write the 1 in front of the square root. So then there's our answer. X equals 1 plus or minus square root 5. All right, so let's look at a modeling problem here. So a diver jumps from a platform 10 meters above the surface of the water. Diver's height is given by the equation h equals negative 4.9, or negative 4.9 this time because we're in meters instead of the negative 16, which is for feet, plus 3.5 t plus 10, where t is time in seconds. What is the time the diver's height equals 1 meter? So let's substitute that in. So we get 1 equals negative 4.9 t squared plus 3.5 t plus 10. So we want to solve, so we need to subtract that 1 over, and we get it set equal to 0, and we get negative 4.9 t squared plus 3.5 t plus 9. Now here's one of the reasons quadratic formula is nice, is we have decimals, but quadratic formula does not care. And so we get negative b, which is 3.5, plus or minus the radical of b squared, which is 3.5, minus 4a, which was a negative 4.9, and then our c, which is 9, all over 2a, which is 2 times negative 4.9. Okay, now we go ahead and simplify this. We can also just type this all into a calculator. So typing the radical into there, we get x equals negative 3.5 plus or minus 188.65 all over negative 9.8. Simplifying, so take the square root of the 188 and gives us x equals negative 3.5 plus or minus 13.73 all over negative 9.8. So then we get negative 3.5 plus 13.73, and then divide that by negative 9.8, and that gives us a negative 1.04, and then negative 3.5 minus 13.73, and divide that by negative 9.8, and that gives us a positive 1.76. Now we are talking about time as we go back to this original problem, so negative does not count, so it took 1.76 seconds to reach the height of 1 meter. Okay, so go ahead and do your practice problem there, number 13, and then once you think about what is the advantage of using quadratic formula over the previous methods we have learned.